Pleasure to be here. My name is Sharon. I'm a grad student at Weizmann Computer Science. I'm doing this project totally unrelated to my day job with Temporal and University of Let's get started. One of the most important lingering questions in science communication is what affects public attitudes towards scientific issues and socio-scientific issues. As Esther skillfully outlined before, there are at least two models that attempt to answer this question in different ways. First is the deficit model. This is what was referred to yesterday as the conveyor belt from the ivory tower, delivering scientific knowledge to the public, and they're expected to interpret it the way scientists do, and in turn, love it the way scientists do. This is a very narrow assumption that has been challenged by the newer public engagement in science model, which acknowledges that scientific knowledge does play a role in shaping public attitudes towards science, but also that values, emotions, ideology, social identity, and public trust in science and other institutions also play a very important role in determining how the public views scientific issues such as climate change, stem cell research, and other topics we've talked about in this conference. We theorize that two other aspects in public engagement with science that haven't perhaps given enough treatment in research are public interest in science and, more broadly, public attention to science, whether they're interested in it intrinsically or for extrinsic reasons. And these two aspects might be very dynamic. We don't know how they change over time. Led us to our research question, which is, what affects public attention to science over time? We answered this question using, similar to a previous study that we did, searches and Wikipedia visits on a weekly basis. And also we had very few keywords to work with. We had to come up with our own keyword list. And we came up with two groups of keywords, terms. First, ad hoc terms, and second, cyclical terms, which we'll hopefully explain. Our 94 ad hoc terms were terms that were typically mentioned in scientific news, are perceived by the public as something novel or unexpected, which is why they appear in the news in the first place. We're talking about terms that would appear in recordings of scientific discoveries that receive Nobel Prizes, such as quasi-crystal, an Israeli Nobel Prize, natural disasters such as tsunami, and difficult to predict astronomical events such as meteor shower, difficult for the average person. Cyclical terms cover all sorts of other scientific terms, learned at school, directly observed, and from previous research we know that these are searched seasonally over the year, and that they are easily predictable in terms of the scientific phenomena. We're talking about school science concepts such as physics or ozone, international observance days such as World Diabetes Day, and easily predictable astronomical events such as the summer solstice. The way we evaluated public attention to these terms is by looking at how the search volume or visits would change over time, but specifically how quickly they decay. Those of you who have taken any physics will know of the term half-life. And this refers to how quickly some radioactive material decays, and we applied this for how quickly search volumes for certain terms decay. The more slowly it decays, the longer the half-life. Here you see half-life number 2 is longer than number 1. Specifically, we were interested in the following questions. First, are there differences in public attention spans to ad hoc and cyclical terms, or are they about the same? Between ad hoc events, such as the Nobel Prize announcements and the laureate's name, and the scientific concepts that underlie those discoveries, like the term discovering, terms appearing in the reason the laureate received the prize. Second, more generally, what are the dynamics of scientific information seeking on the internet? Which comes first, Googling scientific information or looking up scientific information on Wikipedia? Can we observe this difference on a weekly basis, which is what we used in our study? What is the half-life of each behavior, and can we find correlations between these data sets? For technical reasons, we only had weekly data to work with. And with Google, we also didn't have absolute numbers of searches, but we could normalize the data we did have to the week with the maximum amount of searches. For Wikipedia, thankfully, we did have absolute numbers of visits. Our data spanned 264 weeks, from December 2007 to December 2012, which is a similar time frame that Ido researched. And for lack of time, I can only show you some selected results. First, public attention spans to ad hoc terms are much shorter than to cyclical terms. We're talking about a factor of 5. Here, cyclical terms have half-lives in 54 to 129 weeks on Google. Whereas in ad hoc terms on Wikipedia, we can find an average half-life of 9.6 weeks, just over 2 months. Next, peaks of Google searches and Wikipedia visits typically happen in the same week in ad hoc terms, but not in cyclical terms. In the table you're about to see, the rows are the two groups of terms we looked for, and the columns delineate where the peaks are in relation to each other. If they happen in the same week, they're in the third column. If they're more than 3 weeks apart, they're in the last column, mismatched. But if they precede each other by just less than 3 weeks, then they're respectively either Wikipedia would precede Google or the other way around. We found that in cyclical terms, the peaks have practically nothing to do with each other over time, but that in ad hoc terms, 50% of the terms are matched, and 11.7 of the terms are briefly preceded by Google. We found no examples of ad hoc terms where people look them up on Wikipedia before they Google them. Also, peaks of Nobel laureates' names and their discoveries often happen in the same week. Not always, not even most of the time. We're talking about 40 or 50% of the time they happen in the same week. But also here we find a lot of mismatches. This is, in my eyes, the most interesting figure of our study. Terms denoting Nobel Prize-winning discoveries have longer half-lives than the laureates' names. And I like to call this the ripple effect. You can see here in the gray lines the names of the laureates. You see a peak in their Google searches right after the name of the laureate is announced. And also the discovery goes up, but the laureate's name decays very quickly, but whereas his discovery keeps on going. People keep Googling quasicrystals, magnetoresistance, and other scientific discoveries many weeks after they've stopped Googling for the name of the laureate himself or herself. Usually you see a dip right after. Nobel Prize announcements are typically in October. The dip is Christmas break. After New Year's, people start Googling for the discovery again, not for the laureate. So see this both for Wikipedia and for Google. Discussion. To conclude, our findings strengthen the public engagement with science model over the deficit model, because it shows us that the public has its own preferences what scientific information to consume, and those preferences will vary over time. It's not sitting at the end of some conveyor belt waiting for whatever scientific information will come its way from the ivory tower. Next, public attention to newsworthy ad hoc scientific concepts is quite short. As short as 9 weeks on Wikipedia. Data points like these could be important for planning scientific communication campaigns in the future. Ad hoc terms also typically see bursts of the public attention on Google and Wikipedia, which start often in the same week or with Google briefly preceding Wikipedia. And also, the Nobel Prize ripple effect we observe demonstrates a stable public demand for scientific information for occasional perusal. It's no coincidence that people were looking up the Higgs boson video right after Higgs boson Nobel is announced. They want to have this information, they want it accessible, and they want it in their language. It's important to point out 3 limitations in our study. First, findings might not be applicable to publics without internet access. Today we heard 30% of Israelis don't have internet home. We don't know what their interests in science are from studies like these. Next, as I told you, regrettably, the minimal time unit we could work with was 1 week. It would be really interesting to evaluate daily or hourly dynamics within the first minutes after announcing the Nobel Prizes. And the intentions of searchers cannot be inferred from our data. We know that people are Googling for cosmic crystals, but we don't know if they're generally interested in this term or because they were told to do so from their teacher at school. That's about it. Thank you very much.
Yeah, I'm amazed by this ripple effect, actually. This would be my first question. So, would you argue that it's kind of a good thing that to have a hype of a certain scientific topic in the public media to then infer a constant reflection of this scientific topic in the weeks or months or years after that? Because if you have this novel announcement or so, you get people looking for graphene or whatever, it keeps going on.
I think that there's this often, people have complained yesterday that there's this assumption that people aren't interested in science. Science won't sell. There's no point in reporting science in a newspaper.
Do you have a sense of whether that's like a very small slice of the population or a pretty good slice of the population?
For that, we need to compare total, we'd have to normalize that. Total Google searches and the total Wikipedia searches. Definitely a very interesting direction for future research.
In our previous studies, we were able to look at different concepts and compare them with other concepts. So we have a fairly good idea of how much people are looking for scientific concepts versus non-scientific concepts. So you don't have the numbers, but you can have relative trends. And you can see that most of the things really, well, not most of the things, but something like 20% of the words that people look for about science are actually this type of thing, so ad hoc things. They heard about something, they learned about something, and now they go and search for it. And then it becomes like very big numbers, but for a very short time. So if you look at the Google Ads, for example, where you actually pay to get a word, that if somebody searched for a word, he will get to you, then you would not get high numbers for these words because it's really short, but the bursts are very big.
Like, did you say 20%?
20% of the words that we searched for behaved in this way, that people were searching for them because they heard something in the news. But the rest, it's more like I search for it because it's in my homework, probably.
On Wikipedia, we have also the absolute numbers of visitors, so you can estimate how much is it relative to other very popular entries. I think that I don't remember now the actual numbers, but I could see that during the periods of the Nobel Prize announcement, there is a very high interest. It appears in the news in the first headlines in many countries, and people are interested minutes worth. And we were so following the coverage of the news. So it's a considerable amount of people, even me.
Round of applause.